In this lecture, we will discuss about reservoir, its types, various types, and the capacity of the reservoir. So first, what is reservoir? Dams. Dam, you know that it is a type of hydraulic structure. So dams are generally constructed across any river or any stream to create reservoir. And reservoir is an artificial lake. That means it is a man-made lake, man-made storage structure. It requires careful planning, design, construction and operation finally to make a reservoir, which is a huge hydraulic structure. So there are various purposes why we need to construct a reservoir and to store the water. Like the first purpose is storage, next is flood protection, third distribution of that storage water, and there are also various multiple purposes like irrigation, water supply, hydraulic power generation, navigation for recreation purpose, development of fish and wildlife, and soil conservation also. So what are the types of reservoirs? The first type is known as storage reservoir. The types are basically named as per the purpose of the reservoirs are constructed. So storage reservoirs are also called as conservation reservoirs because they are used to conserve or store the water. These are constructed to store the water in rainy season majorly and to release it later when the river flow is low and when from the river we will get a low quantity of water. So in the dry period we will get the required amount of water from storage reservoirs. Second is flood control reservoir, which is constructed for the purpose of only flood control. It protects the nearby areas on the downstream side from the damage due to flood that can happen. Third is retarding reservoirs. It is a type which is provided with spillway and sluiceway. Spillway and sluiceway ways are another type of hydraulic structures which are required to construct with any reservoir. So it is provided with spillway and sluiceway which are ungated. They may be gated with gate or without gate. The retarding reservoir stores a portion of the flood water when the flood is rising and releases it later when the flood is receding. When the flood is reduced, the flood quantity is reduced, then with the help of gate, the amount of water will be released. Next is detention reservoir. It stores excess water during flood and releases it after the flood. It is almost similar to storage reservoir but is provided with large gated spillway and sluiceway to permit to operate the flexibility of releasing the water. Next is distribution reservoir. It is a small type of storage reservoir to tide over the peak demand of the water of any area for maybe municipal water supply or maybe irrigation purposes. The distribution reservoir is helpful in permitting the pumps to work at a uniform rate. So pumps are also used with distribution reservoirs. It stores the water during the period of lean demand, means when the demand of that area is less, and supplies the same during the period of high demand, means when the demand of that area is high, means in summer season, from the distribution reservoir water can be conveyed to that particular area. Multipurpose reservoirs that are constructed for various multipurpose uses. Another type is balancing reservoir. It is a small reservoir constructed to the downstream side of the main reservoir for holding the water released from the main reservoir. So in Sundarnagar, the lake is an example of balancing reservoir. So now we will get to know that for the planning of a reservoir, what investigations should an engineer will do. Means at the planning stage, what surveys, what investigations are required, or what information we should know before designing and before construction. First is engineering surveys, then geological investigations and hydrological investigations. So first is engineering surveys. As we know, it will conduct the survey work will conduct for dam, reservoir and other associated construction work. Topographic survey of that area is carried out and the contour plan should be prepared first. The horizontal control is usually provided by triangulation survey and the vertical control by a precise leveling. Different curves and maps like area to elevation, storage to elevation, land map, property map, site selection map, etc. are prepared. Geological investigation. Why we will do a geological investigation? Because some information about the geology of that reservoir area or dam area we should know first, like the water tightness of the reservoir area. Basin and area are same. Second is suitability of the foundation. So foundation should be strong. So where we will get the rocky mass or the soil with strong foundation. Next is geological features over the ground and also under the ground. Groundwater condition, it means where the groundwater table lies under the exposed surface. Location of rocks under the earth surface, where we will get a rock mass which is a suitable foundation layer we can consider. The nature of subsurface geology can be explored by boreholes or by geophysical exploration. So under the exposed area or exposed earth surface, boreholes are generally drilled and by layer we will get the layer thickness of rock or soil, maybe of clay or soft clay or maybe loamy layer, etc., etc. And also the groundwater condition layer of level of groundwater table. Next is hydrological investigations. From the hydrological investigations, we will know the runoff pattern and the storage capacity for a given demand. Runoff pattern means how much of the water will flow if a rainfall happens on a particular area over the land surface. And to determine the maximum discharge, spillway capacity and design at the particular site area. So the storage capacity, mainly the storage capacity, and discharge, that means the maximum quantity of water that can be discharged from the reservoir area, we will know from the hydrological investigations. So the hydrological regarding the hydrological data or information, we will know in the next semester, 6th semester, under hydrology subject. So how we will select a site area? First, we should estimate the storage capacity. Afterwards, in the next few more slides, we will know how we will get the storage capacity. So first, for site selection purpose, the storage capacity is the main thing, most important point. So the storage capacity should be large. River valley area of that river where we will construct a dam and reservoir should be narrow. The valley area should be narrow. That means the width of the river should be narrow. Length of the dam which is to be constructed, which is less. Water tightness of reservoir. Good hydrological conditions. From the previous slide, we know what are the hydrological conditions we should know first. Deep reservoir. Reservoir should be deep so that the storage capacity will be large and the width should be less, so the dam to be constructed is with less length and less concrete. Small submerged area, that means the nearby lying area of the river or stream where the dam is to be constructed should be less, so that any life or material loss, if happen, then that will be less. Low silt inflow. Silt deposition is a problem in reservoir. The storage capacity will get less then. So the inflow water, with the inflow water, the silt is coming and it should be less in quantity. So for that purpose, some hydraulic structure, small hydraulic structure, silt excluder, etc. are generally constructed. No objectionable minerals, low cost of real estate, means property of that area, cost of the property should be less. Site should be easily accessible generally. For dam construction, it is generally constructed in a remote place where the site is not at the first time it is not accessible. So this point, site should be easily accessible, we should keep in our mind. Now we are going to the capacity or to the storage capacity of the reservoir. before going to directly the storage capacity, we should know some terms related to that capacity, like yield. What is yield? It is the basically output, that volume of water which can be withdrawn and supplied from a reservoir in a specified period of time. And what is safe yield then? It is the maximum quantity of water which can be supplied from a reservoir in a specified period of time during a critical dry year. Critical time duration means the dry season of a year or a whole year with a dry characteristics, dry condition. During that time, the maximum quantity of water that can be supplied from a reservoir is known as safe yield. Now secondary yield. It is the quantity of water which is available during the period of high flow in the rivers or streams when the yield is more than the safe yield. So it is a secondary type of yield. It means that quantity of water which is available when the yield is more than the safe yield. And when it will happen? During the period of high flow in reservoirs. Average yield, it is simply the average, arithmetic average of safe yield and the secondary yield for a long period of time. Now design yield. Design yield is the yield adopted for the design purpose of a reservoir. Design yield is usually fixed after considering the urgency of the water need, water demand, and the amount of risk involved to construct a dam and reservoir. So now, reservoir capacity. It will depend, the capacity, storage capacity will depend upon the inflow available from the river or stream and what is the demand of the particular area or city where we are going to supply the water from that reservoir. Inflow in the river is always greater than the demand. Then there is no storage required. If it means if the inflow in the river is always greater, then why we should store and why we should build a reservoir? But if the inflow in the river is less sometimes, but the demand is high always from the inflow, a large reservoir capacity is required. So the required capacity from a reservoir can be determined with the help of basically inflow available in the river and the demand of the particular city or area. And for that purpose, there are two methods available. Graphical method using mass curves and analytical method by computation of different data of inflow and demand.